Welcome to Anduski Lectures. Topic is Diffusion Crystals, Crystal Defects, Ficks Laws. Teacher Anand Mohandas. Diffusion. The particle transport in a crystalline solid can be achieved through diffusion. So, diffusion in solids can be due to mainly point defects in the crystals. There are several kinds of point defects: vacancy, interstitial, Frenkel defect, Schottky defect. Let us just look at vacancy. Vacancy mechanism, which involves the migration of atom from a lattice position to an adjacent vacancy. Any crystal contains vacancies. One of the neighboring atoms can jump into the vacancy site and leave a vacancy in its previous position. Interstitial means the interstitial some of the atoms occupy interstitial sites, thereby causing the defect. In Frenkel defect is a type of vacancy defect. In ionic compounds, some of the ions gets dislocated from their original site and create defect. Schottky defect, when cations and anions both are mixing from regular sites, the difficulty is called Schottky defect. A crystal also contains extended defects like impurities, dislocations, stacking faults, grain boundaries. Now let us look at Ficks' first law of diffusion. Now, the concentration difference causes diffusion, we know, generally. So Ficks' first law relates the concentration gradient to the flux J. So the formula is the flux J equal to minus D. D is the flux, the diffusion coefficient, multiplied by d by dx of the concentration of impurity. So the flux per unit area, flux density of a component is proportional to the concentration gradient of that component. That is Ficks' first law. And J is the flux density and C is the concentration of the impurity atoms. And D is a diffusion coefficient, which we usually assume to be a constant. That is all about the Ficks' first law. Now let us look into the Ficks' second law. Ficks' second law is concerned with the concentration gradient changes with time. So the rate of accumulation or depletion of concentration within the volume is proportional to the local curvature of the concentration gradient. That is d by dt of C, which is the concentration, equal to lambda d squared C by dx squared. Here lambda is diffusivity and dC by dt is accumulation. D squared C by dx squared is the second derivative or curvature of the concentration. So the formula is d by dt of C equal to lambda into d squared C by dx squared. Thank you for watching the video. Thank you.